You've walked past poisonous plants your whole life without even knowing it. But they're nothing like the stories say. Tonight, we gently uncover the truth. Welcome to another quiet journey with Sleepy Science Nights. Tonight, we gently travel into the calming world of poisonous plants, a world wrapped in mystery, stories, and long-held beliefs that often sound scarier than the plants themselves. Many people imagine toxic plants as fierce forces of nature waiting to harm anyone who walks too close. But in truth, these plants behave far more quietly, simply surviving, growing, and protecting themselves in ways that we can understand with soft curiosity. In this slow and comforting exploration, we will gently untangle old myths that have followed these plants for centuries. Some myths began with small misunderstandings. Others came from dramatic stories told around warm fires on dark evenings. And many came from the simple fact that humans have always been cautious about the unfamiliar. As you settle into a cozy place, this peaceful documentary will guide you through science, history, and soothing facts about plants that carry toxins in their leaves, stems, or flowers. None of these plants are evil. None are hunting us. They are living organisms that developed chemicals over millions of years to survive tiny nibbling insects, persistent grazing animals, or harsh environments. Understanding this brings a soft and comforting perspective. It transforms fear into gentle respect. Throughout this video, every chapter will soothe you deeper into rest while calmly explaining what is true, what is exaggerated, and what is simply a bedtime story that wandered too far. You will hear about plants with bright colors that are harmless, plants that look delicate yet hold powerful toxins, and plants that cannot hurt you unless you try very hard to eat large amounts of them. You will learn how ancient cultures observed these plants with careful eyes, how early healers discovered their medical uses, and how modern science continues to study them with steady hands. Every segment will be gentle and unhurried, letting your mind drift freely like leaves floating on a quiet pond. Let your breath slow, let your thoughts soften, and let your curiosity rest lightly as we begin Chapter 1, where we explore the myth that poisonous plants are somehow cruel or intentional. In truth, their story is simple, calm, and beautifully shaped by nature itself. Many people believe poisonous plants exist to harm anything that gets near them, as if the plants were guided by intention or emotion. This myth has followed humanity for a very long time. But when we look at these plants with gentle, scientific eyes, we see a much quieter and simpler truth. Plants do not feel anger. They do not plan, attack, or seek revenge. They create toxins for one reason only, and that reason is survival. Millions of years ago, before humans existed, early plant ancestors faced countless small grazers, insects, and hungry creatures that constantly nibbled their leaves. Plants cannot run away. They cannot hide. They cannot grow sharp teeth or claws. Instead, they slowly developed chemical defenses. Some of these chemicals tasted bitter, which discouraged animals from eating too much. Some interfered with digestion, encouraging creatures to look elsewhere for food. And a few evolved into complex toxins designed to protect the plant from relentless herbivores. These toxins are not messages of hostility. They are quiet shields formed across long ages. Even the strongest plant poisons, like the cardiac glycosides in foxglove or the alkaloids in deadly nightshade, evolved not for humans, but for much smaller creatures, such as insects and grazing mammals. To the plant, these chemicals are simply tools. Tools that help it stay alive long enough to bloom, seed, and continue the long line of life that came before it. When we understand this, fear softens into calm awareness. Toxic plants are not out to get us. In fact, humans rarely interact with them in harmful ways unless they are handled carelessly or ingested in large amounts. The idea of a plant plotting harm is a comforting story for the imagination, but nature is far more quiet and neutral. A plant grows, a plant protects itself, and in doing so, it becomes part of a balanced ecosystem where every species has its own way of surviving. This perspective gently shifts the story from fear to understanding. It opens the door to learning about many fascinating details hidden within plant chemistry and evolution. In the next segment, we will explore how these defenses formed and why they are so effective even today. The story of plant poisons begins long before humans appeared. In ancient forests filled with tiny insects and early grazing creatures. Every plant that survived long enough to reproduce had to find a way to protect itself from constant nibbling. Some plants grew thorns, which helped keep large animals away. Others grew thick bark that made their stems harder to chew. But many plants discovered a quieter and more efficient strategy. They changed the chemistry inside their leaves, roots, and stems. This slow shift happened through countless small variations, each one giving a slight advantage. Over thousands of generations, these tiny changes built up into complex natural defenses that we call toxins today. It is soothing to imagine this process not as a dramatic battle, but as a gentle unfolding across deep time. A plant that tasted bitter would be eaten less. A plant that caused a small stomachache in herbivores would survive longer. A plant that discouraged insects with a strong chemical scent would keep more of its leaves. These simple steps slowly shaped the vast array of defensive chemicals we see today in the botanical world. Some of these chemicals act on tiny insects, slowing them down or making them choose another plant. Others affect grazing animals by lowering the desire to continue feeding. Only a very small number of these compounds are dangerous to humans, and even then, they usually require large amounts to cause serious harm. This is why most poisonous plants are more dangerous to creatures much smaller than us. Their toxins were never designed with humans in mind. Instead, they formed as quiet answers to the pressures of ancient ecosystems. Even plants that contain strong toxins behave peacefully in the world around them. They do not release their chemicals into the air to attack passing animals. They do not sense movement or respond with bursts of poison. They simply grow as they always have, holding their defensive chemistry inside their tissues. When we learn this, fear fades into gentle understanding. The natural world is not filled with danger waiting to strike. It is filled with strategies that help each species live just a little longer. In the next segment, we will look at a few examples of poisonous plants and explore which parts of them are truly dangerous and which parts are harmless. Now that we understand why plants developed toxins, it becomes much easier to look at specific examples with a calm and balanced mind. One of the most famous poisonous plants is the foxglove, known for its tall spikes of delicate purple or white flowers. Foxglove contains chemicals called cardiac glycosides, which can affect the heart when taken in large amounts. But the plant does not spread these chemicals into the air or release them through touch. The toxins stay inside the leaves and stems, quietly stored away unless the plant is eaten. Another well-known example is deadly nightshade, also called belladonna. Its berries are glossy and dark, and its leaves hold a compound called atropine. Atropine is powerful, but again, it exists for the plant's protection against small animals and insects. To a human, the plant poses almost no risk when simply observed or handled carefully. Even plants with dramatic reputations, such as oleander, behave gently in most everyday situations. Oleander contains several potent chemicals, yet touching the leaves does not harm the skin. The danger comes only from ingesting significant amounts. This pattern appears again and again in the plant world. Many species with dangerous reputations are harmless to touch. Many require large doses to cause illness. Many have only certain parts that are toxic, while the rest of the plant is mild. For example, rhubarb leaves contain oxalic acid, yet the bright red stalks are perfectly safe to eat when cooked. Similarly, elderberry plants have mildly toxic leaves and stems, but the ripe berries become safe when properly prepared. Understanding these differences helps us replace fear with gentle respect. No plant exists with the desire to harm humans. Their toxins are simply natural tools shaped by time and necessity. By learning which parts of a plant contain these defenses, we gain knowledge that feels calm and grounding. In the next chapter, we will explore the myth that bright colors always signal poison, a belief that is surprisingly inaccurate. A common belief says that brightly colored plants must be dangerous, as if vivid reds, yellows, or purples are nature's warning signs. This idea feels simple and satisfying, but the natural world rarely works in such clear patterns. Many bright plants are harmless, and many toxic plants wear quiet, muted tones that blend gently into the landscape. To understand why, we first need to look at what colors mean in the plant world. Color helps flowers attract pollinators such as bees, butterflies, and hummingbirds. These visitors help the plant reproduce by carrying pollen from one bloom to another. For this reason, many flowers shine with bright petals that catch the eye of passing insects. The purpose of these colors is communication, not defense. They are more like gentle invitations than warnings. Some fruits also use bright colors to signal ripeness, encouraging animals to eat them and spread their seeds. This strategy supports the plant's long-term survival. In these cases, vivid colors are helpful, not harmful. Meanwhile, truly toxic plants often blend into the background with greens and browns that make them easy to overlook. Their defenses depend on chemistry, not appearance. A plant does not need to shout with color when its leaves already contain compounds that discourage hungry animals. This makes the rule about bright colors very unreliable. Some bright plants do contain toxins, but they are the exception, not the rule. For example, the red berries of some ornamental shrubs may be mildly toxic, yet many other red berries are perfectly edible. And many toxic species, such as water hemlock or monkshood, appear delicate and quietly understated. This mixture of harmless brightness and hidden danger can confuse people, creating myths that last for generations. But when we learn the true purpose of plant color, the confusion fades and curiosity replaces fear. In the next segment, we will explore how some of the dullest plants hide the strongest toxins, revealing why color alone can never be a reliable guide to safety. While bright plants often appear dramatic or eye-catching, the quiet, muted plants are sometimes the ones that hold the strongest chemical defenses. This surprises many people because dull colors seem gentle, but appearance rarely reveals toxicity. Take water hemlock, for example, one of the most toxic plants in North America. Its stems are pale, its leaves look similar to simple parsley, and its flowers are small white clusters that sway softly in the breeze. Nothing about its appearance looks threatening or unusual. Yet inside its roots and stems is a powerful compound that can disrupt the nervous system when eaten. Its quiet appearance actually helps it blend into riverbanks and meadows where animals graze. The plant does not warn predators with color because it relies on chemical defense instead of visual signals. Another example is poison hemlock, which looks almost delicate with fine leaves and tiny white flowers. Its pale coloring makes it easy to overlook, yet its toxins affect muscles and breathing when ingested. Even more surprising is the castor bean plant. Its leaves are large and vibrant, but the seeds hold ricin, a potent toxin. The plant does not use color to advertise danger. The colors are simply part of its biology, not a warning. On the opposite end, many bright plants are completely harmless. Marigolds glow with intense orange and yellow tones, yet contain no dangerous toxins for humans. Bright hibiscus flowers shine in reds and pinks, but are gentle and often used in calming teas. Even many rainforest plants with striking colors evolved those hues for attracting pollinators, not scaring animals away. These examples show how unreliable color is as a guide to plant safety. A bright plant may be harmless. A dull plant may be dangerous. Appearance gives clues about pollination and growth, but says little about toxicity. This realization offers a comforting message. Nature is not trying to trick us. It simply uses color for many different reasons, most of which have nothing to do with humans. In the next segment, we will explore why people developed the belief that bright plants are dangerous and how these myths grew over time. Now that we understand that color does not reliably signal danger, it is gentle to ask where this myth came from. Humans have always used visual cues to stay safe, and bright colors often mean caution in the animal world. Many insects, frogs, and snakes use bold patterns to warn predators of toxins. This behavior is called apositism, and over time, humans learned to associate bright colors with danger. When people saw brightly colored plants, they naturally assumed the same rule applied. This belief passed through generations, especially in communities that taught children to avoid unknown berries or flowers. Bright plants became symbols of caution, even when most of them were harmless. Another source of this myth came from stories and folk tales. Colorful plants made dramatic characters in bedtime narratives and cautionary tales. It was easier to say a red berry was dangerous than to explain the subtle chemistry hidden in a dull green leaf. Over time, these stories blended with observation, forming a gentle but persistent misconception. Science now shows us that color has many meanings beyond danger. It can signal ripeness to animals. It can help pollinators find flowers more easily. It can allow plants to absorb or reflect certain wavelengths of light. Color supports life, communication, and growth more often than it warns of toxins. This understanding replaces fear with a soft sense of clarity. When walking in nature, we can admire bright plants without assuming the worst. We can observe their shapes, scents, and patterns with gentle curiosity. And we can remember that toxicity depends on chemistry, not color. In the next chapter, we explore another common belief: the idea that touching a poisonous plant is always dangerous, a myth that often feels alarming but rarely matches scientific reality. Many people believe that touching a poisonous plant is always dangerous, as if the plant could release toxins through the skin the moment your hand brushes a leaf. This idea feels dramatic and alarming, but in reality, it rarely matches how plant chemistry works. Most poisonous plants cannot harm you through simple contact. Their toxins stay locked inside their tissues and do not move easily into human skin. To understand this, it helps to imagine the surface of a typical leaf. It is covered in a thin, waxy layer that acts like a protective shield. This layer prevents water loss, protects the plant from sunlight, and reduces evaporation. It also keeps most of the plant's chemicals inside, safely tucked away from the outside world. For humans, this means that touching many toxic plants is completely safe as long as the skin is intact and you wash your hands afterward. Foxglove, oleander, and even deadly nightshade do not cause harm through touch alone. Their toxins must be eaten or otherwise taken into the body to cause noticeable effects. Nature does have exceptions, but they are few. Some plants contain irritating sap that can cause redness, itching, or discomfort on sensitive skin. Giant hogweed, for example, contains a sap that reacts with sunlight, creating a photochemical burn. Poison ivy, poison oak, and poison sumac contain an oily compound called urushiol that causes an itchy rash in many people. But these plants are irritants, not systemic poisons. They do not cause life-threatening effects unless a rare allergic reaction occurs. Their danger is discomfort, not toxicity. The belief that touching any poisonous plant is dangerous likely developed because people often confuse irritation with poisoning. An itch or a rash feels unpleasant, and unpleasant sensations easily turn into dramatic warnings. Over generations, simple caution grew into a larger myth. Understanding the difference between irritants and true toxins helps calm these fears. In the next segment, we will explore what actually happens when skin touches plant chemicals and why most toxins cannot enter the body this way. Human skin is a remarkable barrier, built to protect the body from countless natural chemicals. It is thick, layered, and covered with natural oils that keep most substances from entering. Because of this, the vast majority of plant toxins cannot pass through the skin. They are too large, too complex, or simply not designed to move through human tissue. This explains why touching many toxic plants does nothing at all. Foxglove leaves contain powerful cardiac glycosides, yet your skin does not absorb them during casual contact. Oleander sap contains potent chemicals as well, but they remain on the surface unless they reach the eyes or mouth. Even highly toxic seeds, like those of the castor bean plant, do not cause harm unless crushed or chewed. The body's natural defenses work quietly and effectively, offering protection that people often underestimate. In rare cases, however, a plant may cause irritation through contact. This irritation often comes from entirely different chemicals than the ones responsible for toxicity. Poison ivy, for example, contains urushiol, an oily compound that binds to skin proteins and triggers an immune reaction. This reaction creates an itchy rash, but it is not a poison entering the bloodstream. It is simply your immune system responding strongly to a foreign substance. Other plants contain sharp microscopic hairs that create small mechanical irritations. Stinging nettles use tiny hollow needles filled with mild acidic compounds. The sensation can be sharp and unpleasant, yet it fades as the skin recovers. Even with these examples, the effects are local and temporary. They do not indicate systemic poisoning. Understanding this distinction helps remove unnecessary fear. Plants do not reach into the body through the skin to cause harm. Their defenses evolved for entirely different reasons and target much smaller creatures. In the next segment, we will look at common myths about specific plants that people fear to touch and gently explain what is true and what is exaggerated. Many well-known poisonous plants have gained reputations far more dramatic than their real behavior. Oleander is one of the most common examples. Its leaves contain potent toxins, yet the plant cannot cause harm by simple touch. Gardeners handle oleander regularly without incident, and gloves are used mostly for comfort, not safety. The true risk comes only from ingesting parts of the plant. Another plant surrounded by myth is foxglove. Its tall, flowering spikes look elegant, yet the leaves contain chemicals used in heart medications. Despite this, touching foxglove leaves does not deliver these compounds into the body. The toxins remain safely inside the plant's tissues unless eaten or processed. Deadly nightshade, or belladonna, also carries a mysterious reputation. Its berries are dangerous when consumed, especially for children, but touching them does not cause harm. The mythology likely grew from the plant's dark berries and long history in folklore. Even plants with strong sap, such as euphorbia species, behave in predictable ways. Their milky sap can irritate the skin or eyes, but the reaction is local and temporary. It is not a systemic poison entering the bloodstream. These examples show that plant myths often grow faster than plant science. Fear spreads through dramatic stories, while real plant biology is slow, quiet, and grounded in chemistry. By understanding how toxins behave, we can approach nature with gentle confidence instead of worry. Most poisonous plants cannot harm through touch. They are simply living organisms that store their defenses internally, unchanged by casual contact. In the next chapter, we move deeper into the idea of intention, exploring the myth that poisonous plants want to kill or harm the animals that encounter them. The idea that poisonous plants want to harm or kill animals is one of the most persistent and dramatic myths in nature stories. It imagines plants as active participants in danger, almost like characters with intentions and motives. But real plants do not think, plan, or choose targets. They simply grow and protect themselves in ways shaped by quiet evolutionary pressure. Every toxin found in a plant began not as a weapon, but as a gentle survival strategy against small herbivores and insects. These creatures nibbled constantly, threatening the plant's ability to grow leaves, form flowers, and produce seeds. Over time, chemical defenses became one of the most effective ways for plants to protect themselves. To us, these chemicals may seem strong, and in some cases even dangerous, but they developed to discourage creatures much smaller than humans. For example, cardiac glycosides in foxglove evolved to interfere with the tiny digestive systems of insects, and to make grazing animals think twice before taking a second bite. The alkaloids in deadly nightshade developed to keep small mammals and wandering herbivores from eating the plant. These defenses are targeted toward the plant's natural surroundings, not toward humans who rarely approach them as food sources. Even plants with powerful reputations behave quietly in nature. They do not release toxins into the air. They do not sense motion or react with bursts of chemicals. They remain rooted, silent, and indifferent. The stories of aggressive plants come mostly from folklore, where danger helps shape memorable tales. Throughout history, people explained the unknown by giving intention to the world around them. If a plant caused illness when eaten, it was easier to imagine the plant as dangerous than to understand the chemistry hidden inside its leaves. In truth, plants do not want to harm. They simply protect themselves in ways that feel dramatic only from a human perspective. In the next segment, we will gently explore how these toxins evolved and why they are so effective at discouraging the small creatures they were meant to deter. The toxins found in plants may seem powerful, but each one has a long evolutionary history shaped by countless interactions with small animals and insects. To understand this, imagine a meadow where early plants struggled to keep their leaves intact. Insects chewed on tender stems. Small mammals nibbled on roots and shoots. Herbivores wandered by and ate anything green within reach. The plants that survived were the ones that produced chemicals that made them less appealing. These were not instant solutions. They were tiny advantages that slowly grew stronger over thousands of generations. Some compounds made the plant taste unpleasant, and animals learned to avoid them. Others caused mild stomach discomfort, teaching grazers to choose different food sources next time. A few chemicals disrupted small biological systems in insects, quietly reducing damage to leaves and stems. Because insects are small, these chemicals needed only tiny amounts to be effective. This is why some plant toxins seem intense to humans, even though humans were never the intended targets. When a chemical is strong enough to affect a tiny creature, it may also have noticeable effects on larger animals if eaten in large quantities. Yet outside of ingestion, the toxin remains harmless. The plant does not use these chemicals aggressively. They stay inside its tissues unless eaten, crushed, or otherwise disturbed. Plants do not chase, trap, or attack animals. They do not respond to the presence of humans. They simply exist with whatever defenses evolution gave them. In this way, a potent toxin is less like a weapon and more like a quiet sign that says, "Do not eat me." This gentle perspective helps soften the way we view toxic plants. They are not enemies. They are survivors. In the next segment, we will explore how dose determines danger and why even potent plants rarely pose a threat in everyday life. One of the most calming truths about poisonous plants is that danger depends on dose. A small amount of a toxin may cause no harm at all, while a large amount may be dangerous. This idea is so universal that scientists use a simple phrase to describe it: the dose makes the poison. This means that even water becomes harmful in extreme amounts, while many natural toxins cause no problems unless eaten in large quantities. When people hear about a deadly plant, they often imagine that a single leaf is enough to cause harm. But for most toxic species, the amount needed to cause illness is far greater than casual contact would ever provide. Take foxglove as an example. Its cardiac glycosides are strong, yet a person would need to consume a significant amount of leaves to feel serious effects. The same is true for oleander. The plant contains potent compounds, but touching the leaves or walking past the shrub carries no risk. Even the seeds of the castor bean plant, which contain ricin, are harmless unless chewed. The shell of the seed protects the toxin, and it must be broken for the chemical to become active. These details show how far reality is from the dramatic myths that often surround poisonous plants. The plants do not harm through presence or intention. They require ingestion and a meaningful dose to have an effect. This perspective brings a sense of ease and clarity. When we understand how plant toxins work, the world becomes less frightening and more fascinating. Our relationship with nature shifts from caution to gentle appreciation. In the next chapter, we will explore another surprising myth: the belief that all dangerous plants look scary, when in truth, many of the most toxic species appear delicate and beautiful. Many people imagine poisonous plants as dark, spiky, or menacing, as if danger must be visible in a dramatic shape. This idea comes from stories, movies, and old legends that give threatening appearances to things we fear. But in nature, many of the most toxic plants look gentle, delicate, or even lovely. Some of them grow pastel flowers that sway softly in the breeze. Others have smooth leaves and graceful shapes that blend into quiet gardens without calling attention. One graceful example is the foxglove plant. Its tall stalks of tubular blossoms look elegant and inviting, yet its leaves hold chemicals strong enough to influence heart rhythms in high doses. Another example is the pretty belladonna plant. Its berries look polished and dark, like tiny beads of glass hidden among soft green leaves. Nothing about its appearance feels frightening, yet its alkaloids are powerful when swallowed. Even oleander, a common ornamental shrub, displays clusters of pink, white, or red flowers that brighten parks and gardens. Despite its beauty, every part of the plant contains toxins stored quietly inside the tissues. The gentle appearance of these plants reminds us that nature does not follow human ideas of danger. It does not place warning signs on poisonous species. It does not paint them with dark colors or sharp shapes. Plants simply grow in the way that helps them survive, and their appearance reflects sunlight, pollination needs, and genetic history, not toxicity. This mismatch between appearance and chemistry can feel surprising at first, but it also adds a soft sense of wonder to the natural world. Danger does not always look dramatic, and softness does not always mean safety. In the next segment, we will explore poisonous plants that look harmless, blending so easily into landscapes that people often overlook them entirely. Some of the most dangerous plants in the natural world are the ones that look simple and familiar. Their harmless appearance makes them easy to overlook, yet their chemistry holds strong defensive compounds. One well-known example is water hemlock. It grows with slender stems, delicate leaves, and small white flower clusters that resemble gentle umbrellas. Its look is calm and understated, yet it contains a toxin that affects the nervous system when eaten in large amounts. Another quiet plant is poison hemlock. Its appearance is almost soft, with fine leaves and pale markings on the stem. Its flowers look like lace and would never suggest danger to someone unfamiliar with it. Yet the plant contains chemical defenses strong enough to affect muscles and breathing if ingested. The castor bean plant also blends beauty with toxicity. Its large leaves spread out like star shapes, and its seeds are smooth and patterned, almost like decorative stones. However, the inside of those seeds contains ricin, a potent toxin activated only if the seed is crushed and swallowed. Even common garden plants can hide mild toxic qualities. Daffodil bulbs contain compounds that can cause stomach discomfort if eaten by mistake. Lily of the valley has sweet-smelling bells of white flowers that sparkle softly in shaded gardens. Yet the plant contains glycosides that can affect the heart if ingested in large amounts. None of these plants look frightening. They do not look frightening in their shape or color. This teaches us that visual cues are not reliable guides for understanding toxicity. Nature does not design plants to warn humans. It designs them to survive the challenges they face. In the next segment, we will explore why humans are naturally poor at recognizing toxic plants by sight alone, and how this misunderstanding shaped many old myths. Humans often expect danger to look dramatic, but plant toxicity rarely follows this expectation. We evolved to notice movement, sounds, and animal behaviors far more than subtle differences between leaves or flowers. This means that our instincts are not well designed to identify poisonous plants by appearance alone. Many early societies relied on trial, error, and careful observation to learn which plants were safe. These lessons grew into stories, warnings, and folklore passed from one generation to the next. But because appearance is unreliable, these stories often replaced subtle plant chemistry with dramatic imagery. Plants that caused illness were described as dark, twisted, or unnatural, even if they looked calm and ordinary in real life. At the same time, harmless plants with bright colors or bold shapes were sometimes labeled dangerous simply because their appearance felt suspicious. This blend of intuition and imagination shaped many of the myths that still circulate today. Modern science shows us that toxicity depends on chemistry, not looks. Alkaloids, glycosides, oxalates, and other compounds determine how a plant interacts with the body. These chemicals are invisible to the eye. You cannot see them on a leaf, a stem, or a flower. This invisible nature of toxins helps explain why misconceptions grew so easily. When people did not understand the cause of illness, they filled the gaps with storytelling. Today, with a clearer understanding, we can admire plants without relying on fear or assumptions. In the next chapter, we will gently shift into a related myth, the belief that medicinal plants cannot be poisonous, when in fact, some of the most important medicines come from species that evolved strong natural toxins. A common belief says that medicinal plants must be gentle and harmless, while poisonous plants must be dangerous and separate from healing. But nature does not divide plants into simple categories of helpful and harmful. Instead, many plants that contain strong toxins are also the source of powerful medicines. This idea feels surprising at first, yet it makes sense when we remember that plant toxins evolved as active chemical compounds. These compounds interact with the bodies of animals, insects, and sometimes humans. Because they interact with biological systems, they can be harmful in high doses, but useful in smaller, carefully measured amounts. One of the clearest examples comes from the foxglove plant. Its leaves contain cardiac glycosides, chemicals that can affect heart function. Long ago, healers learned that small, controlled amounts of these compounds could strengthen heart contractions. This discovery eventually led to the development of Defenseless, a medication still used today to support certain heart conditions. A plant considered dangerous became a foundation for modern medicine. Another example is the deadly nightshade plant. Its alkaloid atropine is dangerous when taken in large amounts, yet tiny measured doses are used in medicine to dilate pupils and manage specific heart rhythms. This delicate balance between harm and healing appears again and again in the botanical world. Even aspirin has a plant origin. The compound salicin was first found in willow bark, and it inspired one of the most widely used medicines in history. These examples show that toxicity is not a rigid boundary. It is a spectrum defined by dose, preparation, and the way a chemical interacts with the body. Understanding this brings a gentle sense of clarity to the myth. Medicinal plants can be poisonous. Poisonous plants can be medicinal. And the difference lies in how humans use and prepare them. In the next segment, we will look more closely at how dose transforms poisonous plants into healing tools. To understand how a poisonous plant can also be medicinal, it helps to look gently at the role of dose in plant chemistry. A chemical that is harmful in large amounts may have helpful effects in smaller, controlled quantities. This principle is one of the oldest ideas in medicine, expressed in the simple phrase, "The dose makes the poison." Many plant compounds interact with the body in ways that can be both beneficial and harmful, depending on how much is taken. For example, the alkaloid atropine from deadly nightshade can be dangerous if swallowed freely. But when measured carefully, it relaxes muscles, widens pupils, and supports certain medical treatments. The same is true for digitalis from foxglove. In large amounts, the chemical disrupts heart rhythm. In small doses, it strengthens heart contractions and helps patients with specific heart conditions. Even the humble willow tree illustrates this delicate balance. In its bark is salicin, a compound that can soothe pain when used in the right amount. Over time, scientists refined this natural compound into aspirin, adjusting the dose and form to maximize its benefits. The idea that medicinal plants cannot be poisonous overlooks the complexity of chemistry. Some of the most effective drugs in history come from plants with strong natural defenses. Their toxins are not flaws. They are active compounds that influence biological systems in predictable ways. When used wisely, these same compounds become powerful healing tools. This understanding can feel comforting. It reminds us that nature is full of substances that can help or harm depending on how they are used. It also reveals why so many traditional healers approached plants with respect, patience, and careful observation. In the next segment, we will explore a few well-known examples of toxic plants that play surprising roles in medicine, from heart treatments to eye care and beyond. Now that we understand the role of dose, it becomes easier to see how many poisonous plants quietly support the world of medicine. Consider the plant known as monkshood or aconite. It contains strong alkaloids that can be dangerous in raw form, yet its compounds inspired early pain-relieving treatments when used in controlled ways. Another example comes from the rosy periwinkle, a plant with gentle pink flowers that grows in warm climates. Its chemicals are toxic to certain cells, and this property led scientists to develop important medications for cancer therapy. In these cases, the toxin's strength becomes a useful tool when guided carefully by medical knowledge. Even the autumn crocus holds a surprising story. Its compound colchicine can be harmful if taken without guidance, yet it plays a valuable role in treating conditions such as gout when given in precise doses. These examples show how nature's strongest chemicals often become humanity's strongest medicines. Plants that evolved toxins to discourage herbivores now support treatments that help people around the world. It is a quiet reminder that danger and healing often grow side by side. Science does not choose plants based on appearance or myth. It studies their chemistry and finds ways to use their unique properties for good. Understanding this helps soften the myth that medicinal plants must be harmless. In truth, some of the gentlest-looking plants contain powerful compounds with both risks and benefits. This knowledge invites a calm and respectful relationship with the plant world. In the next chapter, we will explore the belief that ancient cultures misunderstood toxic plants, when in reality, many early societies had surprisingly accurate knowledge of their properties. A common modern belief is that ancient cultures misunderstood poisonous plants, treating them with confusion or fear because they lacked scientific tools. But when we look closely at historical records, a much calmer and more respectful truth appears. Many early societies understood toxic plants with remarkable accuracy. They observed how animals reacted to different species. They noticed which parts of a plant caused discomfort and which parts could be used safely. This knowledge grew not from experiments in laboratories, but from patient observation across many generations. Some of the earliest medical writings from Egypt, China, India, and Greece describe toxic plants with careful detail. They list symptoms, recommended doses, and safe ways to prepare certain species. These texts show that people long ago recognized the difference between a dangerous dose and a medicinal one. In many regions, healers learned which plants to avoid and which ones to use with caution. They passed their knowledge through stories, teachings, and rituals, often with great accuracy. For example, traditional healers understood the strength of aconite and used only tiny prepared amounts. They recognized that foxglove could influence the heart long before its chemicals were studied formally. They knew that certain berries were dangerous when raw, but harmless when ripe or cooked. These insights did not come from misunderstanding. They came from careful attention to nature. Modern science confirms much of what these early communities already knew. Their understanding was often subtle and grounded in experience, not fear. This gentle perspective helps us appreciate the wisdom that quietly shaped ancient life. In the next segment, we will explore how old stories and myths formed around toxic plants and how those stories shaped our modern imagination. Across cultures, toxic plants often found their way into stories, legends, and rituals. These stories served as gentle warnings and teaching tools, helping communities remember which plants needed caution. Over time, the stories grew more dramatic, sometimes giving poisonous plants magical or supernatural qualities. Nightshade became associated with witches in medieval Europe. Its dark berries and mysterious effects inspired tales of enchantments and potions. Aconite, with its hooded blue flowers, appeared in stories about shapeshifters and protection spells. Even mandrake root gained legends about its human-like shape and imagined magical screams. While these stories sound fantastical today, they served a simple purpose. They helped people remember which plants were dangerous and which needed respectful handling. Storytelling made knowledge easier to recall in times when writing was rare. Yet the myths around these plants often overshadowed the accurate understandings that ancient healers maintained. Most traditional practitioners approached toxic plants with calm precision. They understood how to prepare roots, leaves, or seeds in ways that reduced harmful effects. They also recognized which plants should never be eaten under any circumstances. Instead of misunderstanding toxic plants, many early cultures incorporated them thoughtfully into medicine, ritual, and daily life. The myths created atmosphere and caution, while the real knowledge guided practice. This balance of imagination and experience shaped a deep, respectful relationship with the natural world. In the next segment, we will explore some cultural stories that grew from misunderstandings and how these tales influence modern beliefs about poisonous plants. While ancient cultures often understood toxic plants with surprising accuracy, some myths did form from misunderstandings or incomplete observations. These myths were rarely harmful. They simply added mystery to plants that behaved in unexpected ways. For example, the mandrake root sometimes splits into shapes that vaguely resemble arms or legs. This unusual form inspired stories that the root had human-like qualities. Over time, people imagined that the plant could move, cry, or influence human behavior. In reality, the mandrake root contains simple alkaloids that affect the nervous system when eaten, nothing more. Another example appears in stories about the yew tree. Its evergreen branches and long life made people believe it possessed powerful magic. The tree contains toxins that discourage grazing animals from eating its leaves. Ancient communities sometimes explained these effects through spirits or curses, not realizing the tree's chemistry was responsible. These stories shaped the way people approached certain plants, adding caution or reverence to everyday encounters. Modern science helps separate the stories from the biology, yet the tales themselves remain beautiful parts of human history. They show how people tried to understand complex natural defenses without scientific tools. They also remind us that imagination has always been part of learning. Today, we can view toxic plants with both scientific clarity and gentle appreciation for the stories that surrounded them. This calm balance allows us to understand the plants more deeply while honoring the cultures that studied them long ago. In the next chapter, we will explore another myth, the belief that poisonous plants are found only in wild or remote places, when in reality, many grow quietly in gardens, parks, and even in our homes. Or mysterious wetlands. This idea makes toxic plants feel distant and rare, as if they belong only to wild places untouched by human hands. But in reality, many common poisonous plants live quietly in familiar spaces, such as gardens, parks, and even our own backyards. These plants often go unnoticed because they blend naturally into the landscapes we create. One of the most widespread examples is the oleander shrub. It grows in warm climates across the world, lining roadsides, decorating public parks, and filling gardens with soft clusters of pink, white, or red flowers. Despite its beauty, every part of the oleander plant contains toxins that evolved to discourage grazing animals. Yet gardeners handle it safely every day because its toxins do not pass through the skin. Another common yard plant is the castor bean. Its star-shaped leaves and patterned seeds make it a popular ornamental species. The seeds contain strong toxins if crushed and eaten, but the plant poses no danger when admired or touched. Even familiar garden flowers can hold mild toxic qualities. Daffodil bulbs, for example, contain compounds that can cause stomach discomfort if eaten by mistake. Hydrangeas, with their soft clusters of pastel blossoms, contain natural chemicals that can irritate the stomach if large amounts are consumed. None of these plants hide in remote forests. They grow beside sidewalks, fences, and window boxes. Their presence shows that toxicity is not limited to wild places. It is simply part of the diverse chemistry of the plant world. In the next segment, we will explore houseplants that contain mild toxins and how they live safely among people every day. Poisonous plants do not only grow outdoors. Many common houseplants contain mild toxins, yet they share our living spaces safely because casual contact poses no danger. These plants became popular for their beauty, their calming greenery, and their ability to freshen the air inside homes. One familiar example is the philodendron. Its heart-shaped leaves and trailing vines decorate shelves and windowsills around the world. The plant contains small amounts of calcium oxalate crystals that can irritate the mouth if chewed, but touching the leaves is completely safe. Another example is the peace lily. Its elegant white blooms and dark green leaves make it a favorite indoor plant. Like the philodendron, it contains oxalates that discourage animals from eating it, yet it poses no risk to humans through casual handling. Even the Defenseless, often called the dumb cane, has a similar chemistry. If the plant is chewed, it can cause a temporary burning sensation, but this effect does not occur through simple touch. These indoor plants show how toxicity exists on a spectrum. Their mild defenses evolved to protect them from small herbivores, not from humans. Because we do not eat houseplants, the small amounts of toxins they contain rarely matter in everyday life. In fact, their presence in homes demonstrates how comfortably humans and mildly toxic plants can coexist. They offer beauty and calmness while quietly holding chemical defenses meant for entirely different creatures. In the next segment, we will explore how poisonous plants thrive in urban environments, growing along sidewalks, vacant lots, and city gardens in ways that may surprise us. Poisonous plants also grow in busy cities, where people walk past them without noticing. Urban environments create small pockets of soil and sunlight that allow many plant species to thrive. Some of these species carry mild or moderate toxins, though they pose little risk unless eaten deliberately. One example is the common yew tree, often planted in parks and around public buildings. Its deep green needles and red berries make it appear calm and elegant. Yet the seeds inside the berries contain compounds strong enough to discourage animals from eating them. Another urban resident is the lantana plant, found in planters and public gardens for its bright flowers. The plant contains mild toxins that protect it from grazing animals, but humans rarely interact with it in harmful ways. Even wild nightshade species appear in vacant lots and along sidewalks, blending quietly among grasses and other small plants. Their berries look delicate, yet urban wildlife knows to avoid eating them in large amounts. These city-dwelling plants remind us that toxicity is not a rare trait limited to remote forests. It is a natural part of plant defense, found in places where people live, work, and relax. Despite this, harmful encounters are extremely rare. People do not usually eat unfamiliar plants growing near sidewalks, and most toxic species require significant ingestion to cause illness. This perspective helps soften the myth that poisonous plants belong only to wild spaces. They grow wherever conditions allow, quietly sharing the world with us. In the next chapter, we will explore another related belief: the myth that eating a single leaf of a toxic plant is fatal, when in truth, toxicity depends on dose, preparation, and the part of the plant consumed. A widespread myth says that eating a single leaf of a poisonous plant can be instantly fatal. This idea can feel frightening, as if nature hides invisible dangers in every corner. But in reality, most toxic plants require much larger amounts to cause serious harm. The idea that one leaf is enough comes from dramatic stories and exaggerated warnings passed between generations. The truth is far gentler. Plant toxins usually work in proportion to the dose consumed. Just as a tiny amount of salt is harmless, but a large amount can be harmful, plant compounds follow similar rules. Most poisonous plants contain chemicals that evolved to discourage herbivores, such as insects or grazing animals. For these creatures, small amounts may be effective. But for a human, who is much larger, it often takes many leaves or berries to experience significant effects. For example, foxglove contains strong cardiac glycosides, yet a person would need to ingest a meaningful handful of leaves to face real danger. Deadly nightshade berries are toxic, but a single berry rarely causes serious symptoms in adults. Even the yew tree, with its potent seed toxins, requires multiple swallowed seeds for a dangerous reaction. This is not to say these plants are safe to eat. They are not. Their chemicals can cause discomfort or illness when consumed, especially in children or animals. But the myth of instant fatality from a single leaf does not match how plant chemistry works. Understanding this can replace fear with gentle respect. It reminds us that plants do not hide sudden, invisible dangers. They hold natural defenses that act gradually and usually require significant ingestion. In the next segment, we will explore the difference between realistic and exaggerated risks, helping separate calm fact from dramatic fiction. To understand the real risks of poisonous plants, it helps to gently compare common fears with scientific evidence. Most toxic plants can cause illness, but only when eaten in meaningful amounts. This is why accidental poisonings from plants are extremely rare in adults and usually mild when they do occur. For example, daffodil bulbs can cause nausea if eaten, but they do not cause sudden, severe poisoning from a single taste. Rhubarb leaves contain oxalic acid, yet a person would need to consume a large portion to experience anything more than temporary discomfort. Even oleander, a plant known for its potent chemistry, usually requires ingestion of several leaves or a concentrated preparation to cause serious effects. The idea of instant danger comes mostly from stories, cautionary tales, and misunderstandings about plant potency. Movies and fictional books often exaggerate toxins for dramatic effect. A single leaf becomes a deadly trap, and a taste becomes a life-threatening event. But real plant toxins act in slower, more predictable ways. Symptoms often appear gradually. The body may feel discomfort long before reaching dangerous levels. This gives people time to notice, respond, and seek help if needed. Children are naturally more sensitive, but even then, ingestion of a tiny amount rarely leads to severe outcomes. Understanding this reality helps soften fears and encourages thoughtful awareness instead of alarm. It also shows that plants are not hidden threats. They are quiet organisms with defenses designed for insects and grazers, not humans. In the next segment, we will explore how fiction, folklore, and dramatic storytelling helped strengthen the myth of the deadly single leaf. The belief that a single leaf can be instantly fatal grew largely from stories rather than scientific facts. In many cultures, plants with strong reputations became symbols of danger, even when the real risk was far more limited. Folklore often magnified plant toxicity to teach children caution and to explain mysterious illnesses in times before medical knowledge. Nightshade berries, for example, appeared in countless tales where a single bite caused dramatic consequences. These stories helped people remember to avoid the plant, but they exaggerated its true potency. Literature and theater also played a role. Dramatic scenes often showed characters collapsing instantly after touching or tasting a poisonous leaf. These portrayals added excitement and tension, but they did not reflect how plant toxins work in real life. In reality, the body responds gradually, and most toxins require larger amounts than myths suggest. Even ancient healers understood the difference between danger and exaggeration. They recognized that plants could harm in large amounts, help in small amounts, and cause little effect when tasted accidentally. The myth of the deadly single leaf grew because it was simple, memorable, and easy to share. But modern understanding offers a calmer and more accurate view. Plants are not swift or silent threats. They are quiet organisms with defenses that require significant exposure to cause harm. With knowledge comes comfort. By seeing through the exaggerations, we gain a clearer sense of how gentle and predictable plant chemistry truly is. In the next chapter, we will explore a final myth, the belief that humans are defenseless against poisonous plants, when in truth, our bodies and traditions contain many quiet protections. Another common myth suggests that humans are helpless against poisonous plants, as if we have no natural defenses or ways to protect ourselves. This idea makes plant toxins seem overwhelming, but in truth, humans have many quiet protections built into the body and into culture. The first and most important protection is our sense of taste. Many toxic plants taste bitter or unpleasant. This natural signal encourages people to stop eating before consuming harmful amounts. Even children instinctively reject extremely bitter leaves, preventing accidental ingestion. Another protection comes from our digestive system. The stomach breaks down many plant compounds slowly, giving the body time to respond and signal discomfort long before reaching dangerous levels. This early warning feeling prompts people to stop eating, rest, or seek help. Humans also have enzymes in the liver designed to break down natural chemicals. These enzymes help process a wide range of compounds found in plants, reducing their strength and allowing the body to remove them safely. These systems evolved not for poisonous plants specifically, but for the enormous variety of natural chemicals humans have encountered throughout history. Cultural knowledge provides even more protection. For thousands of years, communities observed which plants cause discomfort and shared this information through stories, warnings, and traditional wisdom. People learned which plants to eat, which to cook, and which to avoid entirely. This shared knowledge lowered risks long before modern science began studying plant toxins. All of these protections show that humans are not fragile in the face of plant chemistry. We carry natural instincts, bodily defenses, and cultural wisdom that gently guide us. In the next segment, we will explore how cooking and preparation further reduce plant toxins, adding another layer of calm protection. One of humanity's greatest natural protections against plant toxins is cooking. Long before people understood chemistry, they discovered that heat, soaking, and preparation could transform plants from dangerous to safe. Many mild toxins break down when exposed to heat. Cooking softens leaves, denatures proteins, and changes chemical structures in ways that make them easier to digest. For example, the oxalic acid found in some leafy greens becomes far less concentrated when cooked, reducing the sharpness of its effects. Beans contain natural compounds that are harmful when raw, yet boiling removes these chemicals completely, making them nutritious and safe. Even roots like cassava, which contain toxic cyanogenic compounds, become safe after peeling, soaking, and cooking. These steps may seem simple today, but they represent generations of careful observation and shared learning. Human cultures developed these methods through patience and experience, not through fear. The knowledge allowed communities to use a wider variety of plants for food, even species that would otherwise be difficult or unsafe to eat. Fermentation is another gentle tool. Cultures around the world discovered that fermentation breaks down certain plant chemicals and improves digestibility. Pickling, drying, and grinding also change how the body absorbs compounds. All of these techniques show that humans are not powerless. We have always used creativity and curiosity to work with the natural world instead of fearing it. This balance between careful preparation and natural defenses has protected people for thousands of years. In the next segment, we will explore how humans learned to identify safe plants and avoid dangerous ones long before scientific tools existed. Long before chemistry and modern medicine, humans learned how to safely navigate the world of plants using observation, memory, and shared experience. This knowledge acted as a gentle guide that protected communities from plant toxins. People watched which plants animals avoided. They noticed which leaves caused stomach discomfort and which roots tasted pleasant when cooked. They learned that some berries were safe only when fully ripe, while others remained harmful no matter the season. Parents taught children to avoid unfamiliar plants, and elders shared stories that made important warnings memorable. These lessons formed a natural safety net that existed long before written language. Over time, people identified patterns. Plants with milky sap often caused irritation. Plants with glossy dark berries needed caution. Flowers with strong fragrances were treated with respect until their effects were understood. These rules were not perfect, but they guided people safely through daily life. Humans also learned through careful experimentation. They tasted plants in tiny amounts. They prepared them in different ways. They observed reactions, always starting small and proceeding slowly. This patient approach allowed people to discover safe foods, healing herbs, and plants that should be avoided entirely. The idea that humans are defenseless against plant toxins overlooks this long history of learning and adaptation. In truth, humans developed instincts, traditions, and methods that gently protect them. By combining natural awareness with cultural wisdom, people created a safe, balanced relationship with the plants around them. With this final myth explored, we are ready to end our journey with a soft, peaceful epilogue that brings all of these ideas together. As we reach the end of our quiet journey through the world of poisonous plants, it is peaceful to pause and reflect on what we have learned. Many of the myths we explored began with fear or mystery, yet each one softened when we looked gently at the science behind it. We discovered that toxic plants are not dangerous enemies. They are simply living organisms that protect themselves with quiet chemical defenses shaped long before humans walked the earth. We learned that bright colors do not always signal danger, and dull leaves do not always mean safety. We learned that touching a poisonous plant rarely causes harm because most toxins remain locked inside the plant's tissues. We saw that medicinal plants and poisonous plants often overlap, sharing powerful compounds that can both heal and harm depending on dose and preparation. We explored the wisdom of ancient cultures who watched nature closely and understood much more than many people realize today. And we learned that toxic plants grow not only in wild, mysterious forests, but also in gardens, parks, and quiet corners of city neighborhoods. Yet, despite their presence, these plants rarely pose danger because humans have instincts, traditions, and natural defenses that guide them safely. Even the scariest myths about sudden danger fade when compared with the calm, steady truth of plant biology. Through all of this, one idea shines softly above the rest. The natural world is not here to frighten us. It is here to be understood, respected, and explored with gentle curiosity. Toxic plants are part of that world, adding depth to ecosystems, supporting wildlife, and even contributing to medicine in quiet and surprising ways. As you settle deeper into rest, let this knowledge soothe you. There is no hidden danger lurking in the leaves. There is only nature, calm and patient, doing what it has always done. Thank you for joining this peaceful journey tonight. May your dreams drift as softly as petals on a forest breeze, and may your curiosity lead you gently into tomorrow.